已解锁，请取出话筒。
怎么？还冲凉？还是要带冲凉房的？Hey, good morning to everyone. You try do the homework question. You meet any problem or not? If you have any problem, we can discuss together. And I posted all the solution for you already. You can refer if you don't understand, and then you can ask. Then we can try and discuss here. Okay, if there's no so we have left series chapter, all the power series and the forest series. We're gonna start with curve. Is this what you do in AAG or not? You do parametric curve. You need some. Okay, so we'll start with that. These are the cool stuff in vector calculus. After we introduce curves, then we'll try and do derivative, and then we do integral, and then this course will finish. Okay. Quite fast. Yeah. Okay, so before we introducing curve, so let's review something about real numbers. So what's real numbers? Okay, so let's define it. What's real numbers here? So the real numbers, or sometimes we call it a real line. Okay, how is it a line? Which we denote by this in latex, you put math dbr. Okay, is what? Is the set of all irrational and rational numbers. All rational and irrational numbers. So how does this real line looks like? Usually we'll draw a straight line like this. Okay. Without n. Okay, no n to it. So there's no infinity inside here. There's no negative infinity inside here. Okay, without n. What numbers is inside this real line? Any idea? Maybe one of you give one. Let's start with Bomping. What do you think is inside this line? All the integer. Or Bomping want to take all the integer. Okay, let's take all the integer. 0, 1, 2, 3, 4. -1, -2, -3. Okay. How about Isaac? What else inside this line? Seems like a lot of gap here. What else you can put? Integer over 2. Okay. So you add half of it, right? 2 over 1 is 1, right? So we already have it. So keep adding others. How about 小本呢? What else you think is inside here? Sorry? What irrational number you know? What? You don't know? You say you want to add irrational number, but you don't know what is irrational number. What irrational number you know? Don't know? Don't know. Okay. Right. Never learn about irrational number. Sorry? Can't define. Oh, okay. I mean, sure. Right. So what's the irrational number? These are the numbers that let's define it. So what is irrational numbers? So these are the numbers that cannot be expressed in the form of m over n. Okay, where m and n is in z. Okay. But did you guys prove any irrational number or not before? In what course? Discrete math. What number is irrational? Square root 2, right? Yeah. You should at least know one. Square root 2. Okay, so where is square root 2 inside this line here? Square root 2 equals to what? 7. 1, 4. 1.4. Maybe around here. 1 point what? 1.4 what? 1, 4. And then anyone remember? No. Okay, something like this. Okay. And 小分 呢? Pick one more that we never mentioned before. What number is inside it? Sorry, 那是小分小羊. 小羊. Sorry? What number I can put inside my real line? Sorry? What's the range? Anything inside real number. What else you can put inside this line? Real number. Yeah. Rational and irrational. What numbers are rational and irrational? Three over four. Sure. So where's 3 over 4? Around here. 3 over 4 should be around here. 4.75. 今年 pick one number. What else we haven't mentioned? 选一个，不可能不会 real number 零有吗？选一个没有的啊，一有吗？五有吗？哦，没有，很好。So we add another five here. Actually, just now we mentioned all integer already. Okay, all integer. Right. So you can imagine that we can keep filling in all these gap, okay, with real numbers. So that's why we draw this real number as a line. Okay, although between every two number there's a distance, but within the distance can still fill in the numbers. Okay, this is about the density of real numbers. Okay, or the completeness of real numbers. Okay. Right. So actually you can imagine how we add this square root 2 here. You can imagine it as a limit of a sequence. We learn sequence, right? Okay, so we can realize this square root 2 as a limit of a sequence. So sequence of what? Actually, we can realize, so let me put here, square root 2 is the limit of a rational sequence. So how do we define this rational sequence? You simply just take the decimal expansion of square root 2, for example. Obviously, there are other ways to do it, but this is one way. Okay, then you can see that this will converge to square root 2. Okay, so typically this is how we build this irrational number. And because we can't really write down the whole expression of decimal expansion of irrational. So important thing inside this real number is what? They are, like Boon Ping said, they are integer. Okay, inside integer we have natural number. Okay, so what are natural number? I think we mentioned before, right? We start with 1 in this class, is it? Okay, 1, 2, 3, 4, so on. And then Z is in rational. Okay. These are all the ratio m over n, where m over n is in Z. And rational is in real number. Okay, so these are the number that you need to sensitive about. Okay, natural number, integer, rational, sorry, natural number, integer, rational number, and real number. Do you think there are more rational number or there are more irrational number? More irrational. How do you know? How do you know? Huh? You guys learn cardinality in history. Yeah. So what you guys learn? Not that. Okay, do you guys learn like the enumerable or countable and uncountable, right? So real number is uncountable, but rational is countable. But if you take countable things away from uncountable set, it's still uncountable. And so that's why irrational is uncountable. Okay, so actually there are more irrational than rational, but there are really a very few irrational number that we know, right? What kind of irrational number that you are exposed to? For example, square root 2, e, Euler number, or pi. So they are the most used irrational number. Okay, so there are actually more irrational number to be discovered. All right, so after real number, there's one more definition that you need to be familiar about, which is a function. Okay, actually last time we talked about function already, but let's mention again. So now we just define a function from R to R. So what's a function? Okay, so function simply assign an element in the domain, okay, to an element in the core domain. Okay, x2 fx. So let's give an example of a function. For example, what? So let's give a very easy example. For example, fx equals to x. Okay, so this is what we call the identity function. So this is an identity function. So what does this function do? Okay, so let's check on some point here, right? So what does it do to 0? It sends 0 to 0. Sends 1 to 1. Sends 2 to 2. Okay, so in principle, right, what you have learned before was you can sketch the graph of this function. Okay, so what's this graph of function? So you just plot all the point. For example, when x equals 0, you get 0. Sorry, here is 0. Here is 1. Okay, and then when it's 2, you get 2, and so on. So if you join these points together, what you get is a straight line. But this straight line is not f itself. Okay, this is what we call the graph of f. So let me put here. This is called the graph of f. Okay, so what you plot here actually is a graph of f. This whole thing here. So how do we define the graph of f? So the graph of f. So let me put here. Graph f. How is it defined? These are all the set of s what s fx. Okay, such that x is in. Okay, so this is a graph of. You have a function, you can sketch a graph of f. But if you think about this graph again, what are you really doing here? So again, you see, you are mapped from R to R. So how do I ask you to imagine this R here? Okay, just now we draw a R as a line. So you have a map from a line to a line. Okay, you have a map from a line to a line. And so what can you imagine here is you map the x-axis to this slanted line here. Okay, does it make sense? So what you do is, let me remove all these. I'm gonna do real math here. Let me remove. So what did you do? So you take a real line here, you map it across F, you put it into R2, and then you can see how this real line x-axis here change in R2. Can you imagine? Imagine. Okay. So this x-axis here is your input. And then you see that this input here gets slanted in R2. Okay. Does it make sense? But it's important for you to imagine these map geometrically because later we'll do R2, R3. Okay, higher dimension. So it's important we can draw it up. Does it make sense? So don't just understand this function as one input, one output, one input, one output. So you should be able to see in the space. 听明白吗？OK 啊，Yeah，你要把它们画出来，看它们的几何，也看它们的 geometry。OK， right. So far, any question? Any question? So in this following topics, we'll talk about function from or R to Rn or R2. Any questions so far? No? Okay, can follow. Right. Cool. So we'll start the new topic today. So this topic is about parametric equation and polar coordinate. Our midterm will probably cover until this chapter. I will make announcement again. Okay. Okay, so let's do the first one. This is the curve defined by parametric equation. Okay, so the map from R to R is what you learn in calculus 1, right? So in vector calculus here, you could imagine the R line can be really, how to say, run randomly. I would say it runs randomly in our space here, maybe. Okay, but how do you imagine this line? How do you imagine this line? Do you walk like this? 你是不是这样走路啊？有可能吗？这样走路？什么人会这样走路啊？喝醉的时候。Okay, so maybe you trace someone who are drunken. Okay, 喝醉的时候这样走路。So you can imagine a particle walk like this. But if you have such line, could you define a function to describe it or not? Why not? So yeah, why not? You immediately shake your head. Why not? Huh? Not one. Not one to one. Many to one. Where's the many to one here? Huh? Not one to many. Not one to one. It's many to one. So what's the many to one here? For example, this part here. If you consider this x, if you want to define a function, so this x has to go to the upper point or lower point. You have to go to both. But this is not a function. What did we say about function just now? Every point in x has a unique effect. And all. Okay. But we have a remedy for this problem here. We introduce a new variable. Okay, we introduce a new variable t, which is the time. Okay, meaning what? We want to introduce a variable such that for these 2 points, they have the different input, which is time. 时间. Okay, maybe you walk here at the time of 1 second, the other one 2 seconds. Okay, so by doing this, actually we introduce an orientation on this curve, so we know where to start first and then where to end. Okay, the result of introducing this t here, we have an orientation. So orientation meaning which way you go first and then which way. So can you see that there are 2 orientations here? You can either go to the right or either you go to the left. Okay, depend. So we have a remedy here. So let's define a plane curve can be defined by a pair of parametric equation. Okay, so what's this parametric equation here? X following a function in terms of t and y following a function in terms of t. And we can always rescale. Okay, no need rescale, just take t from any closed interval AB. So why we have xy here? Because this curve is living in plane. Okay. So imagine if you live in like 3D here. 3D here, what path you can trace? For example, fly. You know what is fly? You know what is fly? Fly. 苍蝇对，学校的食堂有没有苍蝇？有，是不是？你如果看它这么飞，这么飞，这么飞，你去 trace to 一个 path 在 R3。And in that case, you need what? X, Y, and Z. Okay, so you can generalize this parametric equation in Rn, okay, when n greater than 2. So what does a parametric equation mean? Parametric here refers to what? Parameter. Okay, so what's the parameter here? The parameter is the t. So your coordinate depend on t. So meaning I give you a time t, you can tell me which point you are at. Okay, like t1, what is the x1? t2, what is the x1? t3, what is the x1? Okay, give me a time, I know your location. 比如说现在几点了？9:25，然后我就会给出 Isaac 准确的位置，在 A5 几 G002里面的第一个桌子的蓝色的桌子，有两个蓝色桌子啊，有字的。OK， 都给出一个准确的位置。Get X1。Okay, good. So about these, so we have fixed. You see, our time has starting and end, right? 我们时间有开始和结束的。Okay. So what's the starting point here? We will call that this starting point to be the initial point, and then the ending point we call the terminal point. Okay or not? Initial means start, terminal 是终点。Okay, bus terminal. Okay, 巴士停的终点。Okay, terminal. So let me remark here. So the initial point is what? Is when the time start. And the terminal is what? Is when the time stop. Okay, FB, GB, FBGB. Okay, is it clear? So this is the basic idea of this curve. Right. Okay, continue. So let's do some exercise first. Let me give you some exercise. You do it now. Okay, so let's write down this curve defined by the following parametric equation here. So the x variable follows the function t squared minus 2t, and the y variable follows t plus 1. And then my time has no start and no end. Okay, so I'll try and plot this. Okay, so I gave you a table, right? I gave you a table, try and work it out. What is x and y? Okay, let's give you a table and then try and work it out. And then try and graph it in 2D because we only have x, y here. And try to get this value. I give you 2 minutes. Okay, try and get these x, y values and then try and plot it out. Plot it. What this curve looks like. Try and compute this. After you compute it, please try and plot it out. Guess what's the pattern? What's the shape of this curve? Okay, so can anyone tell me when t goes to -2, what's the location? What's the SY? 8 and -1, good. Negative when t equals to -1? How about when t equals to -1? 0, 1, you sure? 0, 1? How about the others? Correct. 3, 0, right? Okay, it's 3, 0. 0, 1 is for the next one, right? Okay, so 3, 0. How about when t equals to 1? -1, 2, and then continue. 0, 3, 3, 4, 2 or 3? You sure? 2 啊？33936 Okay, 2. Wow, I'm bringing this mistake for 2 Seng. Next one, eh? Which one? Which one? 3 or 2? 339减6，哎，3啊，9减6，3，哎，你看，不要讲话的话，就会被先讲的人拿掉了咯。所以对的人要最好讲话，不然就被人家拿掉了。Okay, he goes to 4 then. 啊，F5. Okay, agree F5 Okay, good. So we plot these points out. Okay, so we plot this point. So when times equals to -2, it is 8 minus 1. So 8 minus 1 here. Let's say, okay, equals -1, 3, 0. So we plug a 3, 0 here. So 0. And then t goes to 0, which is 0 and 1. And what else? Uh, -4, 2. So -2 here. 0, 3. 3 here. And 3 and 4. So 3, 4, top. And then 8, 5. 8, and then higher a bit. So let's link them together. And let's link them together. So you can see that our curve is going from -infinity to infinity. So not that we didn't put equal here because real line don't have negative and real line don't have infinities. Okay, so we don't put negative here. Equal sign here. And you can see that we have an orientation of this curve, right? So the orientation is going from the bottom to the top. Okay, bottom to the top. Because we order our number from negative to positive. Okay. And what else you observe on this curve here? Quite symmetric. Is it symmetric? Okay, so symmetric around where? Y equals to 2, right? Okay, good. Yeah, symmetry around y equals to 2. Okay. Yeah. This is not a coincidence, Not a coincidence because x is what? T squared minus 2t. So this is a quadratic equation or quadratic function. Okay, with what? There's a root for this quadratic equation here. Okay, quadratic function is symmetric. Okay, right. So actually there's another way to represent this curve, right? Do you know how to do it? So let me claim here. You can represent this curve using x equals to y squared minus 4y minus 3. Hey, when you see this, do you think I'm lying to you? Hey, how come can write into a function? Just now you say cannot. Sorry? This is not a function? Uh, right. I mean, this with respect to y is not a function, but it is a function with respect to, sorry, what am I saying? So if you consider this function as x in terms of y, it is a function. But if you see it as y in terms of x, it's not a function. Makes sense? So meaning what? Meaning we don't view the function as in this way. We instead view the function in the other way. Okay, sometime we can do this. But later we'll learn something called polar coordinate, which is a polar curve, maybe like this. Then no matter how you view it, it won't be a function. But we still have remedy to it later. Okay, we still have remedy to it. But that one will be a next part. But for this part here, do you know how to get this? You learn in AAG how to get this. So you substitute, right? Using t. You're using t to substitute. So how to do it? Should we do it together? Or do you know how to do it? What do? You can express t in terms of y. And then you just sub t equals to the expression of x. You understand? Okay. Yeah, so try work it out. Okay, try exercise for you. Try work it out. This is a revision for your AG. I will write inside the note also. Okay. But let me show you the other way. What if I still still want to express this function using y in terms of x? Can I do that or not? Is there any way to do that or not? How? Easier. Split to two, huh? So how to split? How to split? Which left and right? This one. Okay, let's do what you say first. So y squared x. Left and right plus one, like this. And then okay, you factorize, you mean, right? Y square. And then second half, take square root. Okay. Then you move your -2 to the other side. So become +2. But what does this mean? This means you split your y into two parts. Do you know where you split this into two parts in this picture here? Where you split the two parts? You can verify that it actually happens here. Okay, you can go and try it and verify. How to verify? Just put x, compute y. You can put x and then compute y. You can see that you split this curve into these two parts. But when you split them into two parts, is it true that you can express in function again? Because already single value. Correct or not? The problem with before was with a single x, you have two y values. But when you split into this Eigenhalb plus minus already, then you split this curve into two parts, which in each part there's unique effects that you can assign to. Does it make sense? 听得明白吗？明白我讲什么吗？明白吗？ Okay, let me write clearer here. So the top part here, the top part here, wait, let me write. So the top part here, we can label as y equals to 2 plus square root x plus 1. And then the bottom part here will be y equals to 2 minus square root x plus 1. Does it make sense? So the top part is described by one of the square root. The bottom part is described by the other square root. 好吗？同学，好吗？不同方法再讲一个东西。Okay. And then this concept actually is quite deep. We define a further concept is called Riemann surface. Okay, Riemann surface is built by this kind of patching. So we patch these two square root at this point here. So this is what Riemann surface do, or Riemann manifold. So we patch different functions together, or patch different shape together. Okay. Does it make sense? Okay. Okay, but anyway, in this topic, this part is the main point. Okay, this part is supplement to what we want define using P. Okay, how about next curve here? Maybe you can take a break after this curve. So next curve is the most 最重要的你如果不会这个，你不可以出这个 calculus 2的门。这个是最重要你要学的一个 curve。most important curve you need to learn in this course. So it's defined by x equals to cos t, y equals to sin t. And then this t is going from 0 to 2. Okay. So cos t, so if you try and do this, if you try and compute the all these, try some points inside this 0 to 2, 5, you can try and plot it. Okay? But we'll play a trick here. So there's a trick here. You remember any trigger formula or not? About cos and sine? I think the easiest one to remember is what? What's the easiest trigger formula you can remember? How we can sine square plus cos square equals to 1. Okay, so this is the trigger identity. So if we set cos square t, cos t to be x, so we have what? X squared plus y squared equals to 1. You know what is this? X squared plus y squared equals to 1. Circle. So this is a what? This is a unique circle centered at the origin. So what does it mean by unique here? This means the radius is 1. Okay. So whenever you talk about circle, there's two things to determine the circle here. One is the radius. One is the center. Okay. Once you tell me these two things, I can draw the circle for you. You know why? Why? 什么是圆圈 ？Fundamental problem. What's a 圆圈 ？What's a circle? You fix the origin. Okay. 中心. You take the radius, distance away from this origin, and then you take all the points that have the same distance from this origin. OK 吗？什么是圆圈？圆圈就是所有的点 such that 不知道怎么 such that 它的距离从那个中心点是一样，你才可以画出这个圆。OK。So it's the same distance. So what is the distance here? The distance is 1 in this case. So how do you read this off? You learn that x squared plus y squared equals to r squared in general. So the r here is 1. Okay. So let's draw this. So let's draw it. We draw this. So we have a circle with a radius 1. We have a radius 1 here. Okay, like this. So the first point should be 1, 0. So what's the orientation here? So there are two orientation, right? Either clockwise or anti-clockwise. So what do you think? What's the orientation here? Clockwise or anti-clockwise? Anti-clockwise. Is it true? So you check when t equals 0, where is it? T equals to pi over 2, where is it? Pi, where is it? 3 pi over 2, where is it? 2 pi, where is it? Okay, so you can check that it is actually a anti-clockwise direction. Okay. So you do the same substitution that we did just now, and then you can check that when t equals to pi over 2, it is this point here, and then when t equals to pi is the other point, and then pi over 3 pi over 3 is at the bottom here. Obviously, when time equals 0, it started as 1, 0. Okay, so you need to compute for what is t equals 0, t equal to pi over 2, t equal to pi, and then so on. Okay, so you compute what are the x and y. Okay, so you just compute. Just check these points. Does it make sense? Is it clear or not? Clear? Okay. Yeah. I mean, in general, maybe the curve will get more complicated, but this is the basic thing we do. Just hook in the right domain, okay, and then compute what's the image. Okay, what's the image of x and y under this time. Okay, right. So so another question again. Since this graph is drawn on this curve is drawn on x, y, plane, right? Can you write it as a function of y in terms of x or not? Can you do it? Please, I want to try again. Yeah. Just the answer also can. Okay, so basically, if you can get this equation already, then you can try and manipulate it. But what does this mean? Again, what does this mean? Y equals to plus minus square root 1 minus x. What does this mean? How do you cut this circle then? Or before that, have we determined where the x we can take? Where we can take these x? You see, it's dangerous, dangerous, 危险你们小心If you define something like this, right, make sure you tell people where I can take the t. Where's my domain? In other words, 明白吗？等于不重要重要是我的 domain 在哪里。If I change this domain, it will change. Imagine if I change this t, the endpoint of this t to, let's say, 3 pi, what happens? What happens if I do 0 to 3 pi? Meaning what? I loop around and then I go into the other half round. Does it make sense? Make sense or not? If you don't believe, you get a compute. What is when t equals to 3 pi? Okay. So meaning this when I increase or decrease the time, I will make this curve. I will loop this curve different time. Okay. Does it make sense? 明白吗? So let's say for example, I reduce it. I reduce to pi. What happened to my circle? If I reduce to pi, let's say I reduce to pi here. What happened to my circle? My circle only go from t equals to 1 to pi, half of it. Okay. Does it make sense? So domain is very important, domain. Okay, so in this case here, what's the domain here? How to graph the same curve here? Where do you take your x? Look at here. It's going from -1 to 1. Okay, so you can see from this curve here. Okay, maybe I label this. It's better. So we are taking value from -1 to 1. Okay. So -1 to 1 here. Okay, but like what we discussed just now, right? If you draw this vertical line here, we can never associate 1x to a single point using function. Okay, but turns out that if I just look at the top part or the bottom part, I can associate a function. Okay, so what's this top part and bottom part here? This is what given by the square root here. So which one describe the top part? Which one describe the bottom part? So you can, if you go and check, substitute the value, you can see that the top part is described by y equals to square root 1 minus x squared, and bottom is described by y equals to negative square root 1 minus x squared. Okay, you don't really have to check actually. You know how to see immediately. Yes, positive and negative value in this case here. Square root always give you what? Positive number. Okay, so the positive square root is always positive, but the negative square root is always negative. But immediately you can see from this graph here, there are two parts. One is positive, one is negative. Still, you can verify it if you substitute appropriate x. Does that make sense? Okay, okay. So this is another example of Riemann surfacing. Okay, where the top part is glued to the bottom part at these 2 points when they agree, put them together. Okay. Any question? Any question? No? Yeah. Okay, so whenever I give you a plan curve, you can try and dissect them this way. Yeah. Yeah. Right. Okay, I mean, should we take a break? We can take a break. Any question? If no, let's take a break until 10:03. Huh? 这么打工的不讲啊，一就不可。我没有看到你去剪的那个步骤，不确定你们怎么用这个，所以我就是直接看出。你有没有感觉？像你刚才讲的这个步骤，这个东西要写出来，线条线的，对吧？是啊。其实啊，你这个很难读的，真的，因为我要去挖某个边，我要去挖什么 A，然后我又要去挖这个东西嘛，要挖好多。所以最好你就一步一步有了这个，然后你就说只有它，然后就明白吧？对吧？你看你要解释，你也是要画这个东西，对，而且不需要介绍这样多了，其实就是不需要介绍这么多名字，因为你就一步一步做，我就看到，就像你这样做，我有了这个，然后我就剪给你看，这样子，就这样。 可是你这个有证明很明显，这样显你看不是很明显，因为有一个减有点危险。如果是加的话，肯定会有危险。减的话，你就要其他人有在这个啊，会，等一下我们讨论，还是等我们讨论先？我们讨论，你记住一下啊，因为反正你等下还要问我嘛，对不对？等一下统一跟我讲一下加你几分。好，怎么便宜？ Huh? Okay, testing. Okay, right. Let's start again. So let's do one exercise. I'll let you think about it. So exercise. Again, find a circle equation. Okay, but this time I want to make a random origin or random center and random radius. Okay, so let's set the circle to be centered at a point hk in R2 with radius R. Okay, so think about how we adjust our formula to get parametric equation for circle. Think about. Okay, so I mean okay, in this course it's very important that you can draw. OK，你一定要会画在这个板上面，不要画什么蒙娜丽莎啦吧，就画圆圈吧，圆圈直线。At least you need to know how to draw this basic shape. So just randomly draw some circle, okay? And then see if you can give so meaning if I give you a time t, do you know how to associate a time to this point? Okay, to associate time to this point, meaning what? You need to know how to describe this point. Okay, you need to know how to describe this point. So what ingredient you need? You need the x-axis and the y-axis. You need the x coordinate and the y coordinate. So can you describe x and y coordinate? Okay, so this is the thing you need to talk about. But I gave you more than this circle, right? What did I told you? I told you what is the center. And what else I told you? I told you the radius. So from these two info, can you figure out how to tell the xy point? Okay, xy point here, for example, depend on t. Let you think first. Okay, you have to struggle first. I'm not sure I will give you answer. Otherwise, you won't think. Struggle first. Then later I'll give you answer. Okay, so you should imagine this is how you struggle in my assignment. Struggle for 2 minutes, you should get the answer. Trending now. Okay, before I tell you the answer, maybe I didn't really tell you how to get this point from this circle picture here. So how do you understand this T here? So really, you can understand the T as an angle, right? Okay. Implicitly, I told you this is an angle. But what is this cos T sine T here? How do you realize this cos T sine T here? This, sorry, I think I need to remove some extra label here. So this parametric equation tells you what? If you fix a T, what is that point on the T, on the radius 1, on the circle? This point here is exactly cos T sine T. But how do you understand about cos T and sine T? What's the formula you know about cos T? Cos T is what? It's a ratio of what? What's the ratio of cos? Cos T equal what? Adjacent over hypotenuse. So what does adjacent over hypotenuse means? So meaning there's a right angle triangle. So where's the right angle triangle? Can you find the right angle triangle here? Where's the right angle triangle? Actually is this right angle triangle. Okay, so there's a adjacent, hypotenuse, and opposite. 哎，中国是这样教吗？中国怎么教 cos 啊？哎，中国是你回答，这里是中国人呢。Hello，怎么教 cos 和 sin？对，哦，正弦余弦啊，那个 ratio 你们叫什么？正弦余弦是它的名字，是不是？啊，它是谁的比例？啊，对，斜边。OK，还有角边，还有一定有3个吗？我都讲3个出来了。对边，OK，所以黑是什么边？斜边 hypotenuse。A 呢？什么边？邻边。哦，邻边，OK，邻居的邻，对，adjacent 就是邻居，OK，adjacent 就是邻居，hypotenuse 斜边 ，good。哦呢？对边，对面的 opposite，对，跟我们一样，OK，yeah。So cos is what? Cos is adjacent over hypotenuse. So where is cos? So adjacent hypotenuse over hypotenuse. So adjacent over hypotenuse. So, okay, good. Wait 啊，wait 啊，等一下啊，稍等。So so wait. So let me point this out. Let me point it out. So cos t equals to adjacent over hypotenuse. But we know about hypotenuse, right? Hypotenuse is what? Radius 1. So hypotenuse is what? So meaning what? 邻边 is cos t. So 邻边 no? 邻边 here. So here is 邻边. This A here is 邻边. So here this point is cos t, the x coordinate. Okay? Sin t, sin t is so opposite over hypotenuse. Again, we know what is hypotenuse. Is radius 1. So meaning what? 对边 is sin t. So meaning this height here is sin t. So give us the x and y coordinate here. Does it make sense? Okay or not? So we use the fact that we know about hypotenuse. Okay? The hypotenuse is always 1. Does it make sense? Okay. All right, good. So same case here. It's the same case here. Okay, same case here. So how do we do it? So we get our CABN first, hypotenuse. Okay, so this hypotenuse is a R already. It's not 1. Okay, it's R. But that's fine. But we still can get our 邻边 and 对边. Alright. Okay, so what's our 邻边 here? What do you think? Something about cos t. So cos t is what? Cos t is adjacent over hypotenuse, but we know about hypotenuse now, right? Is R. So adjacent become R times cos t. Okay, so this x coordinate is R times cos t. How about the y coordinate? Become R sine. Okay, but this point is given with the reference of the center here. So in total, what do you need to do? What's this point exactly is? You need to shift by h on the x coordinate and shift by k on the y coordinate here. Does it make sense? Okay. Okay. So just now we imagine that this is a center, but somehow we shift the center now. Okay, so you could write that x equals to h plus r cos t, and then y equals to k plus r sine t. Okay, where the t is going from where to where? Going from 0 to pi. Okay, so I mean, you see that 0 and 2 pi is the same point, right? To avoid taking same point, you can either throw one of them away. Otherwise, you repeat the endpoint. Can you imagine if I'm gonna draw, if I'm gonna change this domain here, let's say change to 0t to 2 pi. Sorry, 3 pi, for example. Actually, you see the same circle, but what? You go around once and then plus a half round. Okay, so you need to remember how many times you wrap around. Okay, so this will determine whether you are the same curve or not. Okay, does it make sense? Okay, so there's an orientation on this curve. Okay, going clockwise again. So from here, you also can deduce the general formula for a circle center at hk with radius r in terms of x and y only, right? You know how to do it? In terms of x and y, you have a formula for the circle here. You know how to do it or not? So you can take x minus h equals to r cos t, y minus k equals to r sine t. Okay, and then you can use the trigo identity again, where you get r squared cos squared t plus r squared sine squared t, which is just r squared. Okay, so in all these cases, I demonstrate to you what we can use parametric equation to describe a plane curve, or we can try and get the algebraic equation to describe it. So this algebraic equation here only in terms of xy. Okay, only in terms of xy. Why? Because we can draw our curve on xy. So you just use xy to describe it. But as you can see here, this algebraic equation here is not really a function. It's not really a function. Not really a function, right? Okay, it's not really a function. But like what we said just now, maybe if you can do some algebraic move, such that you can cut your curve into two functions. Okay, if you can describe it as square root or something else, then you can patch the two functions together to get your plane curve. Understand or not? Patch means glue, 粘在一起. Okay, maybe you can use two functions to glue these curve together. Does it make sense? Glue meaning their endpoint is the same. Okay? Or the place when you attach them together is the same point. Okay. Any question? No question? No? No? Okay. So the next question, I think I choose not to discuss first because this question is not pretty precise. And maybe I want to throw it away or either let's see how. Because why? Just like what I told you, right? Even though we know that they describe the same curve, it really depends on the domain you have. Do you wrap the same round or not? Do you wrap twice? Do you wrap once? Although their shape is the same. Okay. So this question is not pretty precise here. I'm not sure this same curve meaning exactly the same time you wrap it around or just represent the same curve. So this question is not really precise, so you can forget first. Okay, if I think of a better way to solve it, and then I will present to you. Okay, no? Yeah, this question not very precise. So yeah, not precise question, I try to throw away. Okay. It will confuse you in future. So better not do it now. Yeah, for now, just follow what I have. What time is it? Maybe you can try one more example here. This example, actually, I didn't go through for the past 2 semesters. Maybe we can go through together now. Okay, let's go through together this example here. This is a pretty nice example, actually. And the solution is quite clean also. And this is a real life example you had. So let's write down what it is. For example, so a cycloid. Okay, so what's a cycloid? Cycloid is the curve traced by a point. Okay, on the rim of a wheel. Okay, as the wheel rolls along a straight line without slipping. Okay, let me ask one person. Hi, Jingyan. You understand what this line say? You imagine this line? 可以理解这句话在做什么吗？什么意思？解释一下。Yeah, good, very good, very good. So 就是说你坐在车上嘛，OK，你的车在行驶的时候，你的轮胎在动，然后你就找你轮胎的某一个点，看它的移动轨迹，OK，and then there's one point very important here，什么叫做 without sleeping？什么叫 without sleeping？不是 sleeping，sleeping 滑滑倒，滑胎是什么意思？什么叫滑胎？胎不会动，胎不会动什么意思？我们看的那个点也不会动。对对对对对对对对，胎不动，对对，往前滑，但是胎不动，对，没有错。如果胎不动的话，那个点是不是也不会动？所以就空身，所以就不是我们要讨论的。我们要讨论是，如果这个轮胎一直动的话，这个点怎么它的运动轨迹怎么样？Okay, so if you try and draw it out, if you try and draw this circle out, what can you see here? So imagine this circle like rolls around like this. Okay, so if you trace it out, you will get something like this. Okay, not quite a circle, but maybe like an eclipse. Okay, not quite a circle, but an eclipse. Okay, does it make sense? So imagine this point go to the top of the rim and then come down to the ground, touch the ground, and then go up again. Okay, so the bottom part is the ground. Okay, then the top part is the top of the rim. Okay, make sense? Okay. So assume that the radius of the wheel is r. Okay, so we derive the pair of parametric equation for this blue curve here. Okay, we're trying to derive it. Let's do it step by step. For the cycloid, 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 cycloid or cycloid? Cycloid. Yeah, cycloid. Bicycle, cycloid. Okay. So this is cycloid. Right. So how do we derive this? So like what I say, right? How to derive a parametric curve here? You need to tell me the xt and yt depending on t. Okay, so the main idea is get me the formula of xt and yt. Okay, so how to get this? A bit out of thin air here. So let's see how we do this. So the strategy is try and look at a small part of this cycloid first. So let's give us an xy axis first. Let's look at a small part first. So where's the small part? So let's look at when you start from ground and then go to top, for example. Okay, and then get your rim ready. Okay. So for example, if my P point here, did I call the point P? Okay, let's call this point P. So if the P point is here, what do I need to figure out? I need to figure out um, what's the X and what's the Y. Correct or not? So I need to figure out what's the X and Y at this point. Let's put P here, and then let's call this point xt and yt. So we need to figure out, depending on t, what is this x and y. So how do we choose our t here? How do we choose our t here? So one way to do it is, you can see that our wheel is circle, right? So can we derive any relation between this circle here with this point? For sure, this P, the movement of this P is controlled by this circle. Correct? For sure. Okay, so can we try and figure out any relation between the circle with this point here? So what can we consider here? Um, there's a way to do it. So what's the way to do it? Let's see. So if we try to draw a point. So maybe let me exaggerate a bit. Okay. So let me exaggerate a bit. So let's move it a bit to the top. And then let's see, how about we introduce this parameter here? So parameter looks like this. So how about use different color? Okay. Then this one, check this point here. So what's the center here? This center is C. Okay. And then how about we relate this point here to the angle T here? Okay. How are we gonna do this? How are we gonna do this? How about I tell you goal first? Do you want to know about goal, or do you want to see how it follows? What do you want? 你比较喜欢有目标，还是你喜欢做一做就做到的？你喜欢这样的啊？Eureka moment。OK，OK，OK。力量啊，目标还有目标，所以有些人一样，有些人要的东西不一样。OK，right. Actually, 目标 is in your pre-notes if you want to look. Yeah, there's a formula that we want to achieve. But how to achieve that formula? So if you draw these relation out, okay, how do we play around with this relation? How do we play around with this relation here? So, I mean, there's something you can check here. I mean, you might think that it's quite random, but this is how we do maths actually. We try to write down all possible relation that we can deduce. And then we only put useful stuff together. Okay, this is a real maths, Real maths is like this. We try all possibility and then we put useful things. But when we present to you, there's only one method. You should ask why I can only solve in this method. Actually, it's not. You can solve in other method if it works. Does it make sense? 明白吗？因为我们中小学的教育就是说，教你这题你就这样做吧，或者顶多教你2个或者3个，不可能只有这3个罢了的，肯定还有第4个、第5个、第6个、第7个、第8个、第9个。Okay, so what we're gonna do here is we try to write down whatever we know, whatever we can deduce. Okay, whatever we can deduce here. So, what's the nice thing about this T? Once I introduce this T, right, I can know this point relative to the center. 用刚才的什么对角啊、菱角啊，知道吗？ But we need to measure our P from this x here. Okay, so somehow we still need to know what is this length here, so that we can cancel out with this point that we know. Okay, so how do we compute this point? Let me do it. So let's say if we have this T here, how do we know about this P here? How do we know about this P here? Actually, let me see. We know that PQ is what? Is R sine theta. Is it correct or not? Where's PQ? PQ. Is it R sine theta here? Anyone check? Sorry, not theta, not theta here. So here is T. Hold on. So where's the right angle triangle here? So it's this one. Okay, based on this circle, right? Do you know P? Okay, with respect to this center here. Okay, so I think I need to write here is with respect to center C. Okay, so where's my Q? I forgot to tell you this is the Q. Okay, so we have this X here and then this Y here. Okay, can everyone check? Is it R sine T or not? So R is the hypotenuse, right? So sine is the opposite over hypotenuse. And then here QC, so cos T, cos is adjacent over hypotenuse R. Okay, so we know this point with respect to this dot here, but we need to know this point with respect to the whole coordinate here. Okay, so we need to count our coordinate from the origin. So how to do it? We need to count from this origin here. So we know this length, but what's left to know is OX, so that we can know X from the origin. I don't know. So what else we need to do here? So we need to do, so let me draw out what we need to find. So instead, we should find what is, so let me make this clear. So this is the X we need to find, and this is the Y we need to find. But what do we know? We only know what is XT, for example. Okay, so this is then of PQ. And what do we know? We know QC, for example. Okay. So in this case here, what is left to find? We need to find what is OT and CT. These are the two things we need to find. CT, you know, what do you think? CT, you know, no? CT is obvious. Center to T. Okay, so it's just Okay, so CT is But what is OT? OT a bit tricky, you know. OT is a bit tricky. Okay, how to get OT? OT is a bit tricky. Yeah, OT. I don't like OT. OT is a bit tricky. You like CT? What is OT? How to figure out OT? What's this length here? Can you imagine? 反走过必留下痕迹，谁走过这条 OT？什么？我谁走过这条 OT？ Guys, this wheel, how it move? This P come from where? Like what I said just now, it must touch the ground first, and then you move up. But how you move up? When you move this P up, what happened to this point? This point have to touch the ground first. Can you imagine or not? You must imagine the movement, otherwise I cannot do this question. So when you move this P up, all these points will touch the ground. Okay, so like what I say, if you consider how far OT travels, what is it? It is exactly what? We see that OT is the arc length of PT. Okay, what's the arc length of PT? So meaning this part is your OT. But how do you compute this part? This is what? This is simply R times T. So in our case, it's T. Okay, so R times T. Okay, OT is R times T. So meaning what? So let's denote here. OT is R times. Okay, good. So time to compute X and Y here. So X is what? X is OT minus PQ. And then Y is CT minus QC. Good. So let's compute it. So OT minus PQ is what? OT is RT minus PQ is what? R sin T. And then CT is what? R minus QC, R cos T. Okay, so we have derived a parametric equation based on T and depend on R. Correct or not? Does it depend on R? 对吗？如果 R 变，它会变吗？能想象吗？能想象吗？ If your radius is higher, right, your cycloid should be maybe larger. Right? Okay, when your ring get bigger. Does it make sense? Question? If you are confused, please ask. About this asking question, like what I mentioned to my AA student yesterday. Maybe I will get faster and faster when we get along. But if you think that I get too fast, you can stop me. And you think that your question is trivial, congratulations, maybe you are true. But still, I still encourage you to ask. Because now I treat you as a baby. You are mathematics baby. Okay, so baby have to do what? If baby poops, what happens? 知道什么叫 poops 吗? Oh yeah, they cry maybe. But who clean it? Baby clean it. Parents, adult. Sure or not? Baby still small, don't know how to clean poops. 大家知道什么叫 poop 吗？大便。OK，现在你长大了，你大便还要你父母帮你擦吗？不用，你不要你父母擦，你还感觉到害羞。OK，所以这是长大的过程。So now it's the same. You just started to learn mathematics. I can help you clean your trivial question first. But when you get along, you grow more mature, then you can solve these trivial questions yourself. 这是很真实的。我带的第一届的学生到现在，他们已经是很 mature 了。他现在跟我做 FIP，我的问题还是他帮我解答。有些他问题我帮他解答，我们互相解答问题。这个就是我们 FIP 该做的事情，而不是在带你一步一步要讲，没有了的。我们是成熟的成人了，对，你有你的想法，我有我的想法，我们互相沟通。这样。So when start is okay, but as you get along, you learn more, then you can solve yourself these problems. Does it make sense? Yeah. So don't feel how to say. Don't feel bad for asking different questions. It's fine. I can help you solve first. Then when times get along, you will solve yourself already. Does it make sense? 明白吗 ？OK, it's the same 啊，这个很正常的东西，就是这样。但很多人会忘记，其实你知道，但是你忘记啊，所以我提醒你们。Okay, good. So I think this is the hardest example we're gonna talk about in this course. Right. What's next? Okay, we can continue. So continue to do calculus now. Okay, finally we're gonna do calculus. So these are just curve. So we will do calculus on parametric curve. So what does calculus mean to you? And whenever you see calculus, what pops up in your mind? Integration, good. What else? Function, okay. What else? Sorry? Limit, good. What else? What? Value theorem, okay. Very good. MVT, IVT, okay. What else? There's one more important thing you guys didn't say. Slope, which is differentiation. Okay, all these is about an infinitesimal study. Okay, infinitesimal study. We want to study locally what happened at the function or at the curve. Okay, at the curve. So these are infinitesimal study. So let's define this. So we're gonna define what is the tangents on parametric curves. I mean, intuitively is easy. So you have a curve, okay? You talk about what's the tangent on the curve. So you draw something like this, right? You draw something like this. But what's this line? So we need to make precise what's this tangent line here. Okay, so let me say this is a point, call it x1, y1, and then this is called a tangent line on x1, y1. So we need to make precise what this means. Okay. So to make precise what this means, we need to have some assumption first. So we need to make sure that we start with two differentiable function. Okay, later I'll tell you where we put this differentiable function and then why we need it to be differentiable. Then what? Remember that this curve always we draw in this chapter here is a plane curve. Plane curve means what? What is plane? Plane refer to what plane? Is the R2 plane. Okay, so in R2 we have two variables x and y. So meaning this is a curve on a plane. Sorry, this is a line on the plane. So meaning what? We can get the slope or get the gradient. What the gradient is? The gradient is dy dx. Okay, so the gradient of this line is also a gradient for this point here. Okay, okay, the gradient of this line equal to the gradient of this point. Okay, we're gonna make this precise here. So we will say that the tangent line with gradient dy over dx, okay, at the point x1, evaluated at the point x1, y1. So what's this point here? This point here is exactly governed by our f and g. Okay, governed by our f and g. So you should imagine that our curve is governed by this f and g. So what's this parametric curve here? This parametric curve is exactly where x equals to ft and y equals to gt. So meaning what? You start with a curve that can be described by differentiable function. Okay? But what we see in this course is always polynomial. So polynomial is always differentiable. Okay, so differentiable curve here. And if you're gonna talk about dy over dx, you should think about y can be expressed as a differentiable function of x. You have seen this example just now, right? We write a parametric equation for circle, and then we can get a y function in terms of x using what? Square root. Okay, we can do that. Okay, we can see that y is also a differentiable function of x. Then what? Then now I'm going to give you this formula here. What is this dy dx defined? This dy dx is defined by differentiating y with respect to t and differentiating over dx over dt. But I think you are familiar to this, right? This is what? Chain rule. Chain rule? Yeah, this is chain rule. We're going to prove this. This is chain rule. Okay? Or to be precise, if I write like this, actually, not very clear. Why is it not very clear? When you write down this derivative, what you really means is you d dt on y, and then you d dt on x. You shouldn't think about 分数 portion. Okay, it's a operator. It is an operator. D over dt on a function. D over dt on a function. This is a proper way to think about this. Although sometimes it's behave like a fraction. For example, you learn in OD the method of separation, right? But it requires proof. Okay, it requires proof. Also, because of this theorem here, also suggests that it works like a function. Because you can think of it as invert dx dt and then dt dt cancel and then equal to dy dx. But when we define d dt, it's not like that. It turns out to resemble some property of fraction. Okay, that's why we have this way of writing. I mean, to be precise, really precise to write down this whole thing, right? I can write in this way. So this is equals to d over dx with respect to t on y on x with respect to t equals to d over dt on y on x with respect to t, and then d over dt on x with respect to t. Okay, so this is the full form. Okay, what's going on here? This is the full form. Correct or not? If my y don't have t variable, how do you differentiate? You cannot. If my x don't have t variable, you also cannot differentiate. If you differentiate, just get 0. Because it's 0 on that variable. It's constant on that variable. This one then will differentiate with respect to xt, the whole thing. Okay. Does it make sense? So whenever you write down this derivative, make sure you differentiate with the correct function, with the right variable. Okay. Good. So what's that line? I haven't told you that line. So I will give you the formula of that line. So that line is just y minus y1 n times the m. What's the m? The slope. Okay. Evaluated x1 at y1 times x minus x1. So this is the straight line formula here. Okay, y equal to fx plus c. Okay, y equal to fx plus c. And then why there's this shift here? Because we shifted the line to x1 and y1. Okay, so this is the definition. So this is the definition. Okay, cool. So this is the definition. So how to prove this? How to prove this equality here? Let's prove this. Okay, let's prove this. So let's prove this equality here. X equals to dy dt over dx over dt. Okay, let's prove this. So I'll prove. So you see that this is a chain rule. It is exactly a chain rule. So how are we going to use chain rule here? So how do we do this? So recall first. Recall that from count 1. Okay, we have chain rule for composite function. Okay, we have chain rule for composite function, for example, f, g, t. Okay, both f and g are differentiable. For differentiable f and g. Okay, so we differentiate. How do we differentiate this? What's the formula here? You get what? d dgt on fgt times d over dtgt. Okay, so this is what you know last time. But how to apply to our case? What do we have in our case here? What's our y? What's our x? We can use parametric equation to describe them. So we describe x as f t and y as g t. Okay, so how are we going to use this? Or if we don't want to use ft st here, right? We can remember what is x and y here. Also can. Okay. But like what we said just now, right? We also have x on, sorry, y on xt by substitution. Remember, like we take the square root for our circle, we can write y in terms of x. Okay, so these are the three things we have. Can you remember or not? I mean, you should have an example in your mind. So whenever we talk about random curve, right, you should have an exact curve in your mind. Let's take an exact curve here. So x equals to cos t, y equals to sine t, and then what sort of x, y in terms of x function we can get here? Which is y equals to, for example, square root 1 minus x squared like this. Does it make sense? Okay. Because x is in terms of t, I can replace this t in if you like. I mean, you can write yt to be square root 1 minus cos t squared like this. Okay, so these are the different ways to write them down. Does that make sense? So I mean, how to use this formula to get that formula? Think about it. I give you 1 minute. Nothing about it. How to use a bottom formula to get a top formula. You just need to do the right substitution and rearrange. Hi, Bing Xiang. Any idea? Okay, right first, right first. You have to write, right first. Yeah, how to rearrange in this case? Yeah, how to rearrange? Okay, I tell you the substitution really, and then I tell you what rules work, or how to rearrange it to get what you want. Yeah, try first. I mean, if you really like mathematics, right, you should see pattern. Where's the pattern here? There's something that didn't change, which is dt. Okay? Top got 2 dt, bottom also got 2 dt. So you need to hope for something. One of the dt terms should be the numerator or denominator. So which one should be a numerator? Which one should be a denominator? Mind you again, the multiplication here is really multiplication, so you can divide. dt is what? Did I swap the wrong order or not? Let me see. I think may I think I do a wrong order, is it? Maybe I do the wrong order, you confuse a bit. How about I said, let me see. Oh, C G X T G on XT G on FT. Okay, maybe I do the wrong order. How about I swap this order? Maybe you can see it clearly. Because if I use that order, then you need to swap G. 没有写错啦，I mean 就是你要自己调。I mean that F and that G is different from this F and this G. This is a general FG. Maybe I fix it this way is easier to see. Easier to see now. Easier to see now. If you sub everything in. Okay, so if we sub everything in, what we have, so FGT is what? F of GT, we seriously got YXT. Okay, and then GT is XT, and then FGT again, XT, and then D of DT is XT. Okay. Just now I didn't write anything wrong, just that if you want to apply a formula, then you need to do a proper swap. But if I write it this way, it's just direct substitution. But if you write this, can you see answer from here? Can see or not? You need to at least see answer from here. So you see that dy over dx is this term here. And then dy over dt, this term. And then dx over dt is the other term. So you just move this dx over dt to the left hand side. Yeah, so it really comes from chain rule. Okay, so it really comes from chain rule. So you can use this formula safely in future. Okay, you can just use this formula. Goes to d over dt by xt over dx over. Good. Okay, any questions so far? Any questions? No. Others? How about others? Any questions so far? So you can freely use this formula next time. Okay, whenever you have these parametric curve here. Okay, this part here. Then you can use this formula. Okay, make sure that your GT and YT is differentiable. Why? From this formula, you already can see why you need your GT and FT differentiable. Why? Because you need to differentiate. Okay, you need to differentiate. So you need your x and y to be differentiable. So this formula here is actually very cool. Correct or not? Because if you differentiate with respect to t on both coordinate, and then you take quotient, and then give you some slope inside your plane. Understand or not? You do two operation on one variable stuff, but after you take quotient, it become a gradient on a two-dimensional space. Okay, because this dy dx, this dy dx happen on the plane, but dy dt ds dt just happens on the line. Okay? And then you take the quotient, how the rate of one direction compared to the other rate of direction. Okay? And then combining them, you can see the rate of change on the two-dimension space. Does it make sense? Okay. Okay or not? Okay. Yeah. Okay. So I mean, in the picture, really, if you consider rate of change on one direction, actually you just look at x direction, how fast it move in this direction, and then how fast it move in y direction. But if you combine these two together, is the gradient on two dimension. Okay, so this is the significance of this formula here. Okay. Yeah. Okay or not? Okay. Okay. So how about let's take another break. We can do one exercise, and then after the exercise, we'll discuss assignment. Let's break until 11:09.啊，学到了。有可能要比去新加坡。哦，6月加5里啊，6月加，还有礼拜六的，他自己 Excel 的2级发现了，他讲一天一题有点不实际啊，想不到可能没去，他想到不实际啊，哎。 我让你来你。
厦门玫瑰那个你买个整子，对，不止便宜点，在靠上这千倍，三个是行。你知道我们旁边的有一个姓不一的住，也啦，也来了，对。那个什么，这可以做到，这个拿这个让你做到，这个体验。所以他 presentation，你的 successful 吗？这里这个啊，是我看 Andy 是被炒鱿鱼，那种时候会在这那条叫起来是真的那个，因为可怜那样子的。然后他面对着审家，下的律师说的，他去一个按摩店问工，然后这个人可以把你照片过来，他讲，嗨，my name is Nicole，我可以看到你照片吗？那个 Alice 人，啊，对不起，我不敢接，我们这里买的，不敢接。
你讲那很傻，我觉得蛮舒服。怎么的？他一拍就拍中不给台北。
是干就开始会感动。
还是有被鼓的一点。
心思哦，跟里面的，你跟他换东西咯？
是啊，你不知道？
你在跟他换东西？你知道吗？你跟那个人讲，那个的，然后我就按了，你看，把给我们，
把你们拍下来呀？是啊，还是自己吗？就是看清楚啊，还是六啊，那其他的按啊，
咱们到这里，那你看刚才我按了，按七了，但是我不知道按六了，你先摇啊，你看你叫 refund 的 refund，这个叫客户，你有没有看过有个区的，把这个东西放进里面？我买一个矿泉水哦，我出来我放点6块7那种，我出来200包东西。
哎，你可以讲的是，
但是我们就一个人在那边，去买，
一个机票啊，一个去谁这个人比那个谁的
这个是比那个多。
对，那个 team 那个谁叫昆女生，
更多的这个
应该不要管他，对不对？
你先排，你那边给我塞吗？你那个塞了吗？讲话，你讲以为我的重点还放在哪个地方？
质量靠海。
切上是把酒当滚水，而不是把这个当滚水，滚水当做冰水熬夜的滚水。哦，可以。对，你啊，你这个，对，加油！我是想问问什么导演？好像没有过有点快，没有过有点快，对，都没有过。哪里？他们这个，哎，哪里？不拿，我再也不碰菜的。现在我的基因那边不在碰菜，你家里不有一次了。IPO 啊，只有这个比较 Q 罢了，但是还是有点 Q。咱们那个数据分的啊，这样抓住。这个数字那边，这是导致三国代数。这个是同性词汇。这个需求有一些的，老师给你记到，他调剂的哪一些？S 里头这个最高的发的在这个，我在想，我 AS 的时候，前度的时候，你知道我给你看咋了？不懂那种感觉，我跟电脑你不是会 A 度了？特别是好，我们几乎把有的上进拿去吃，特别是至少还上进到。下一次哦，老师那个高层这个是进不来，差不多应该这个我也在这边看，
Okay, so let's start. So let's see an example on this theorem here. After this theorem, we can discuss assignment. Okay, so let's look at the specific curve below. So let's look at the curve defined by x equals to 5 cos t, y equals to 4 y equals to 4 sine t when t go from 0 to 3, for example. So whenever I hand you a curve like this, try and plot it out. Okay, it's just like what I did in the first example. Try and plot it out. What is when t equals 0, equals 1, 2, like that. Okay, try and plot it out. So if you want to guess, I want to guess this curve. How do you guess? So this is not much deviates from the circle curve, just that we put some scaling. Okay, so maybe it resembles the circle a little bit. So how about we draw it like this, for example. Okay. So the first question we want to look at. So again, our calculus means what? Infinitesimal study. We want to study around small place. Okay. we want to zoom in. Okay, we look locally what happened. Okay, locally what happened. So for example, let's say we want to find what's the gradient, okay, of this curve at the point, let's say we pick at t equals to power 6. Okay, so I think around somewhere here. Yes, you can check if you are not sure. Around here. So let's say we want to find what's the gradient here. Right. Let's see what's the gradient here. So how do we find this? Just now I gave you a formula, right? Okay, if you are a plane curve, you want to find the dy dx, you can resort to what? So from definition of tangent line, you can resort to what? Resort to the rate of change of the change of y with respect to t over the rate of change of x with respect to t. But can we do this or not? Can we differentiate y and x with respect to t? Can or not? We can, right? Because we have differentiable function. Okay, so we differentiate. In particular, we differentiate 4 sine t with respect to t over, we differentiate 5 cos t with respect to. So I think you know how to compute this, right? So what's the numerator here? Yeah. Oh, good. Denominator, leh? Okay, so this is the dy dx here, but we want to evaluate at that point. So this means what? You see, my dy dx is depending on t, meaning what? I can get you all the dy dx. Okay, depend on which point you like. Which point I like here? I like t equals to pi over 6. So at this point here, what do we get? So we simply evaluate it. So what is 4 cos pi over 6? What is 5 sine pi over 6 here? So if you have calculator or if you remember, this is what? 4 times square root 3 over 2 over 5 times half. Okay, which is negative 4 times square root 3 over 5. Okay, pi over 6 is 30 degrees. Okay. Is it clear? Okay. Right. Next, how about find the second derivative? Okay. So your dy dt, you can see that. You'll see the dy dt is changing with respect to t. So you can again check how this dy dt changes. Okay, with respect to x again. So how about if the question asks you to find the second derivative? Okay. So meaning the change of your gradient. Again, evaluate at the same timing. So how are you gonna do it? Evaluate at t equals to power 6. What do you think? I just tell you how to differentiate once though. How to do differentiate twice. Can you think about 1 minute? How you gonna do it? I just tell you how to differentiate once. You apply to differentiate twice. Can or not? You should think of it like there's a Russian toast or Russian dolls or not? 俄罗斯套娃，能不能套一套？怎么套？怎么套？ So d square y dx square by definition is what? Differentiate dy dx with respect to x. But I told you how you differentiate the function with respect to t, right? Okay, so what is this? You can directly apply the tangent formula, which is d over dt on dy dx over dx over dt. So you treat the dy dx as a new y. But does this make sense or not? Okay, you should ask yourself, does this make sense? Can I differentiate dy dx with respect to t or not? Can or not? Can, right? Just now we express our dy dx in terms of t, right? So we can differentiate with respect to t. And then dx dt we just now calculate one. Okay, so now the question is, how do you differentiate the quotient d over dt of negative 4 over 5 cos t times sin t over sin t over this one we know that is negative 5 sin t. So you use your quotient rule, or if you apply bunch of quotient rules, in the end you can check, you get that negative 4 over 25 sine, sorry, at the bottom, sine cube t. Okay, try and go through the quotient rule here. Okay, you should see the calculation. Okay, so to evaluate, you just plot your t to be pi over 6. Okay, so if you do it at t equals to pi over 6, d square y over dx square is what? It's just negative 32 over 35. Okay. Yeah. Any questions so far? Is it clear? Clear. So the second derivative of dy over dx, sorry, second derivative of y with respect to x, you can apply what you know about first derivative. Okay. I think we'll do the next example next time. Next example actually is quite important also. It's also important for your assignment. We'll do the next example next time to determine a horizontal tangent and vertical tangent. And then after figuring out horizontal tangent, vertical tangent, it helps you to reshape your curve. So meaning you can gain information from this tangent line. So that's why we study tangent line, because it can help us to draw your original curve. And maybe the original curve is not nice, maybe not circle, maybe not ellipse or a nice shape you have. But if you know that how the tangent line change, maybe you can redraw the shape. Okay, we're gonna show you next class. Okay. No? Any questions so far? Any question? You know how to use dy dx formula here? Using chain rule. Okay, this is the main thing you need to know today. Okay, and then what are you really computing? Okay, these are the main thing you need to understand. Okay. Okay, if okay, then we can proceed with the assignment question. Yeah, let's discuss assignment. So you can bring out your Moodle and again handing back to you your feedback. Okay, you can look at it. We'll discuss assignment feedback here. Right, actually I didn't tell you the analysis last time, right? I should tell you. Let me tell you what's the analysis last time compared to this time. So last time actually we have 4 high scorer here around 29, 30. Last assignment full marks 30. So we have Ziying, Isaac, Bumping, and Chung Xiang. Okay, so these 4 persons here. Okay. About this assignment, the total is 40. Okay, so 40 here, the highest score is about 38 and 40. Okay, 38 and 40. So we have Chuang Yu, Xiao Peng, Jing Shen, okay, Boon Ping, 还有凯伦. Yeah, this time. Okay, this time round. Okay, so actually the mean is quite high. Mean is around 80, 78. Okay, so 大家加油啊，蛮强的啊这个吧。大家努力。Okay. So if you have any problems or you want to collaborate or you want to ask you can ask this friend. Okay, you can ask this friend, check answer with them. Okay. Whether your idea is correct or not. Not copying, not copying, but check. Because I give you a lot of time, right? You should go online check, ask friend check, textbook check, check with me also. Office hour. Hey, your class, seldom people come to my office hour. You like to work on your own, is it? Okay, you can work on your own, but if you met any problem, just feel free to come. Okay, and ask. Okay, yeah. Feel free to come to the office hour. Okay, if you don't want to see me, there's other senior there also, if you like. Okay or not? Yeah. Because the other class is very active. Okay, they like to come and make them their usual fixed time to come. So make sure you can't get help. Because I know that my assignment is pretty hard. Why is it hard? Because I test your understanding. So you need to understand first before you do. Okay, you cannot straight away go and find working. It doesn't work. Oh, another thing about my lecture note, right? So Yiping asked about which part got tested, which part didn't tested. So I mean, for some of the material, right, I will write like, for example, it's not examinable or not accessible. So those are the things, if you like to skip, you can skip. For example, like this, I'll tell you that, oh, this part, you don't need to read if you don't want. Okay, you can learn yourself, but it's non-examinable. And then in the end, if you go through this not, I will say that which where ends. Okay, so this whole part, not examinable. And then the other you should read again or go through the exercise. Does it make sense? Okay or not? I will write explicitly which part is not examinable. Which part is not examinable. Any question? Question or not? Is it clear? Yeah, for a series need. Okay, I'll also put into the assignment, right? So you have to learn. Yeah. Okay. Yeah, so when you learn these you need to understand the examiner's mind. Okay. So to learn this knowledge, right? You don't learn page by page, word by word. What you should learn is you should ask yourself, what's this page is trying to say? And then did you get this technique or not, or get this skill or not? This is the main thing. It's not about the word by word, statement by statement. Okay. It's about this exercise, what this exercise want me to do. Is it this exercise want me to use ratio test or whatever test? Okay. Yeah. So this is the more important thing you need to figure out. Okay. Otherwise, you'll get lost in the sea of knowledge. Okay. You'll get lost. Okay. You need to try and extract. If you don't understand, you have to ask me. Okay. You have to ask me. Okay. Let's return to assignment. All right. So first assignment. Okay. I don't want to discuss assignment first. Let's talk about some logic. I found out that your guys, discrete math not good. Not good. Seriously, not good. Okay, seriously, not good. But it's okay. It's okay. You have to learn. Okay. The most important thing is you know good, you have to learn. Okay. So let's see this case here. So let's define there are 3 mouths in this world only. Okay. 2 actually. 2. Okay, 2 lah. I want to find another one, but I can't find it. But never mind. 2 mouths. Jerry and Mickey Mouse. Okay, these 2 mouths. Ratatouille. Ratatouille is mouse, right? Is it? Okay, 好吧 let's edit it. How to spell R-A-T-O-U Okay, ratatouille is now. Okay, thank you. Ratatouille, how to spell Red, huh? Aish, okay lah. Red. Okay, so Jerry, Mickey Mouse, and Red. Okay, so let's say there's a statement here. There's a mouse hit by Tom. There's a mouse hit by Tom. How to prove this statement? You just need to prove that either Jerry, Mickey Mouse, or the rat hit by Tom. If none of them hit by Tom, is this statement true or not? False. Okay, so to prove this, it is enough to show that either Jerry, Mickey Mouse, or rat hit by Tom. But how about if I use it? I want to use it. So I want to use this. So I need to use as assumption. Suppose I know already. I know there's a mouse hit by Tom. Can I say that Jerry hit by Tom? By assumption, can I know that Jerry hit by Tom or not? Can I? Can I say that by assumption Jerry hit by Tom? What do you think? Can I write like this? If I know that there's a mouse hit by Tom, can I straight away deduce Jerry hit by Tom? Not sure. Maybe it's Mickey Mouse hit by Tom. Maybe it's Red hit by Tom. So I'm not sure. Okay. Does it make sense? You cannot deduce this. Why? Because it could be the case that, let me write down properly. Write like this. We cannot straight deduce the above because it could be what? Let me use a table. Let me use a table to summarize. It could be what? So let's say here is hit by Tom. And then let's do 3 column here. Maybe Jerry not hit by Tom, but Mickey Mouse get hit by Tom. And Red hit by Tom. Then you are forced to make the statement. But there is a mouse get hit by Tom. It's true because Mickey Mouse get hit or the rat get hit, but not the Jerry get hit. Does it make sense or not? This is very important. Okay, the exist don't allow you to use any mouse. Only the mouse that get hit you can use. So if you happen to know which mouse get hit, then you can deduce that, oh, Mickey Mouse get hit. It's not because of that statement. Actually, you actually know how to prove Mickey Mouse get hit first. Because there exists didn't tell you which one. It just tell you there's some mouse. If you want to use exact mouse, you have to prove. If you just need a mouse, enough. I don't care whether Mickey Mouse, whether Jerry, whether Red get hit. As long as I have that mouse is here. Okay, now if you want to use an exact mouse, actually you need to prove. It is this mouse get hit. Only you can deduce that, oh, Mickey Mouse get hit. Actually, not that assumption already. The assumption just give you a signal, tell you that there must at least one mouse get hit by the Tom. Who is it? Don't know. Statement didn't tell you what. You need to find it. Okay, so this is very important in your project one. If you're gonna prove something like for every epsilon there exists a delta like that. And you need to find that mouse for me. If the problem is to find the ND. Okay. Does it make sense? Make sense? This is about is existential. Want to talk about universal or not? Want to talk about universal? Understand? How about the other? Universal. Let's talk about universal also. Okay. I think these are the two basic things you have to get it right. Okay, starting today, you guys have to get this kind of statement right. Let's say all mouses get hit by Tom. So if you're gonna prove this statement, how to prove? So in other words, what? You need to prove that Tom, sorry, not Tom. You need to prove that Jerry, Mickey Mouse, and Red all get hit by Tom. All of them have to get hit by Tom. Only you can prove this statement. So that's why Isaac said let it be arbitrary, because sometimes the statement can go through every cases. If cannot, you need to do it case by case. Jerry, prove hit by Tom. Mickey Mouse, prove hit by Tom. Because maybe different, man. Maybe Jerry get hit this way, man. Correct or not? Mickey Mouse get hit this way. Red get hit this way. Different way. If all of them get hit the same way, then you can do it together. Correct or not? Oh, I see that all of them go into hospital because here got injured. And the injury say get hit by someone. And the person is Tom. Make sense or not? Okay. 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 Another thing. So different thing is, how about I use it as an assumption? If I use it as an assumption, what can I deduce? Assumption. All mouses get hit by Tom. Can I write so Jerry get hit by Tom? Sorry, I write the wrong stuff here. So all mouses are hit by Tom. So Jerry is hit by Tom. Okay, so you can write, because we know that all mouses get hit by Tom already. So if Jerry is one of the mouse or not, get hit by Tom. If Mickey Mouse one of the mouse or not, yeah, so get hit by Tom, because all of them get hit by Tom. Does that make sense? So for all this statement is very strong, very strong. No matter what mouse you have, all of them get hit by Tom. Okay, for all is very strong. There exists, you cannot specify to which mouse. Only you know that there's some mouse gets by Tom. Okay, but for all, you can specify now. That's why you learn in the logic of universal specification. Okay. Px becomes Pa. Okay, so this is the significance of what you learn in logic. Okay, it's not just a simple X, A, P, Q. Okay, you need to think of a real scenario. Does it make sense or not? Okay. Okay. So do you understand why I deduct your assignment mark now? Okay. Think again, improve your writing. Okay, improve your writing. Okay, improve your writing. It's okay, because you are still learning. So please learn. Okay, please learn. Okay, please learn. Okay, so these are the two main things about the exists and universal quantifier. Very important on these two statements. Okay, in our mathematics. If you have a variable, you need to quantify it, whether it's the exists or whether for all, for some or for all. Okay, and then two ways to interpret whether you want to prove it is true or you taken it to be true. Okay, two ways to interpret the same statement. Okay. Yeah, any question? Any question or not? Any question? Okay, please get it right since today. If you still confused, you can ask me again. Okay, so please get it right since today. Okay, so first question. Okay, so why I asked you to prove this, because in one of the lecture exercise we use this fact, the fact that if we know that it's decreasing as a function, real valued function, then we can deduce that the sequence defined by this function also decreasing. Okay, so the way we prove here is to use the definition of decreasing using first derivative less than 0. And then I ask you to use this property to show that the sequence defined by this function is also decreasing. True what? How do you relate derivative back to the original function? So that's one way to do it, which is the mean value theorem. Okay, this is the mean value theorem here. I think most of you get it right, just that you didn't write down the sequence you have. What is the assumption you have, and then how this assumption leads you to use mean value theorem. Okay, so let's look at mean value theorem itself first. So mean value theorem says what? Suppose that, okay. So let's see what is being supposed here. So suppose that this function is continuous on a closed finite interval, and it is differentiable. So there's two parts here. So one is continuity, one is differentiability on a slightly different domain here. Okay, one is open interval, one is closed interval. Then what? Only then you will have this result here. So meaning what? You need to fulfill your condition first. 对不对？你跟你妈妈要一样东西，你妈是不是讲你考试给我考好先，我才给你？对，没有考啊，考试考不好，怎么你还可以拿到那样东西？不可以的，对不对？所以 you need to fulfill the condition first. Okay, what's the condition you need to fulfill? Check that the function is continuous on the closed interval and differentiable in the open interval. Why you care about this interval here? Because you want to show that there's a point C such that in between this interval you have that equality here. Okay. So do you have that? Do you fulfill that condition or not? What do you know about F? Look at the question. What do you want to prove? You want to prove that if F is a differentiable decreasing function, then the restriction is decreasing. How to prove this if-then statement? If-then statement, how to prove? Let's go back to logic again. Sure, it's a direct proof. Maybe some of you don't know how to read this P implies Q thing. So let's write down the full logic to you. Why it makes sense to do direct proof here. So if you remember the true, true, false, 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 true, true thing. So what's the true, true, false, false thing? So true, 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 false, false, true, false, false. True, true, what? True, 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 false, false, and then true, true. So why direct proof will prove an if-then statement here? Look at that truth table. Okay, I teach you a way to read truth table that you never read in this way before. So how to appreciate this truth table here? If P is false, nothing to prove. The whole statement always true. Okay, if P is false, always true already. Okay, but when P is true, you need to be careful. If P is true but Q is false, the whole statement false, then you cannot prove that it's true. So the only way to prove this statement is true when P is true is you need to prove that Q is true. So what are you proving is actually this line here. This line is the one you need to prove. Because bottom is P false, you always get true. No matter what is Q. You see, no matter what is Q. Don't care one. Q true, Q false, still true, the whole statement. But when P true, you need to be careful with your Q already. If Q false, this statement is wrong one, you need to provide counterexample. So the only way for this P implies Q to be true is Q has to be true. So this is what you are doing with this truth table here. Okay or not? Okay, so this is what we do. If P then Q. So meaning we need to assume P first. Okay, assume we have P. Then we need to show that Q is true. So P says what? P says that it is differentiable and decreasing. I didn't give you interval, right? Meaning what? Actually, it's differentiable and decreasing at the whole R. No matter where you cut your interval, it's still differentiable, still decreasing. Okay? So, but the question starts with F is continuous. Okay, I got differentiable on open interval already. Does it continuous or not? You need to ask this question. But I give you a hint, right? I said that you can assume that differentiable implies continuity. So you have it. You don't need to prove. But in MA, you need to prove. But here, you don't need. You can use. Okay? So in this class, almost I will give you all the key. You just need to put the key at the right place. Okay? So we have continuity, we have differentiability. Okay, good. Use mean value theorem. We got the mean value theorem now. After we apply mean value theorem, what we know about decreasing? Okay, I put the hint inside your group chat, right? Decreasing is about the first derivative less than 0. So we will know that this quotient here, Fn minus Fn over n minus n is less than 0. It's less than 0. So meaning what? I get Fn less than Fm. Done. Okay, most of you done. Just done like that. But the question says what? I want to restrict my F to only domain n. The mean values theorem work for all R. Why? Do you see the difference or not? One is for R, one is for n. But why is this still true for n? Because n is a subset of R. Correct or not? So you need to see these differences and then how to put these differences together. Okay or not? Actually, it's trivial, but you need to find that thing out. Does that make sense? Okay, you need to find these reasons out. Or you can simply start with, I consider interval Mn, where Mn is n. Straight away, because Mn already live in R. So I straight away get it. Also can. Depend on how you write it. Yeah. Depend on how you write it. Or you can change the order to say, oh, I know that it is true for R, so it is true for n, because n is one of the points. Okay or not? Can you see the logic or not, step by step? In mathematics, all mathematics, you can do this one. Okay, not just this course. All the other course you can do this. Must do this. Even if the lecturer didn't disclose to you, you have to do it yourself. Okay, you have to do it yourself. Right, step by step. Because most of the time, maybe the lecturer slack, 不小心或忘记或懒惰都有可能。所以你自己要把它挖出来。All right. Second case is the converse is not true. Actually, you guys are pretty smart. What you do is you pick, for example, minus x squared. It is true in this setting here, but actually it's not quite what I think. Maybe next semester I want to change this question. Yes. If you look at my example here, this is the example I gave. Because when the first time I think about this question is that I want to make decreasing on the sequence side. And then the other side, actually, I don't care. But turns out that you play around with this side here. It's good. It's good. Yeah, it's good. Because what I want to think about is I have a decreasing sequence, but somehow when I grow the function, it has to increase somewhere. So what I do this precise function here. I use cos. So I do like cos again, cos again, cos again, cos again, cos again. I do this piecewise. Okay, but turns out that you guys play around with this negative side is good. So next time maybe I need to fix my domain. Yeah. Actually, last sem when I come out with this question, nobody thought about that kind of example. all of them talk about this. So they somehow know what I'm pointing to, what I'm trying to play trick with. So I mean, it's okay. It's okay. I think it's good. Yeah, I think it's good. So if next time I want them to do something like this, maybe I need to restrict the domain to positive. Yeah. Anyway, so in this question here, how to give counterexample? How to give counterexample? Counterexample meaning you need to fulfill your condition first. So what condition you need to fulfill first? So converse is what? So sequence decreasing implies the real value function decreasing. Okay, so you need to check that whether your function started with is differentiable or not. Okay, and then check that on n point is actually decreasing, but on the real point it could increase sometime. Yeah, this is the converse, the other direction. But you still start with a differentiable function, so you need to check whether you define the function differentiable or not. Okay, and then you contradict the decreasing. Okay. Yeah. So it turns out that 2,3, yeah, the 2,3,0,4, yeah, they're around this. Good luck. Good luck. Good luck. Yeah. Okay. Yeah. I mean, hey, when you first see this solution, don't expect me to write this down first. I'm not writing this down first. 讲出来哈，很神奇哈，好神奇哈。我先画这张图先。I first get this shape first, and then I think about how I get this U shape. Turns out that, hey, this just looks like cos. Correct or not? Cos is like this, man. All right. So I just make an appropriate scale, and then shift. Turns out that this is the general form. You can verify. Try and verify it. Try and verify it. So I don't come out with these. So mathematics novice 没有这样夸张，就是这样夸张，真没有这样夸张，GSC 没有这样夸张，GSC 没有这样夸张，因为我们以前看我们的 MA 老师的例子的时候也是很奇葩，但是 turns out that 你如果把它画出来，就是没有这么奇葩，画出来很简单。等我画出来过后，我才去 describe 它。你可以用 sin 也可以，sin 也有这一部分呢，可是你要 shift right shift 到对哦。cos 的话就准，可是你要把 shift 拉，就是 cos 拉长一点 ，cos 移一点，对不对 ？You can try and verify. I think it's correct, but you can try and verify it. You can try and verify. If wrong, you can tell me. Yeah. But anyway. Yeah. Okay. Any question? No question. Okay. Yeah. So although I present to you, I write these first, and then these are actually in my mind. I come up with the picture first. I have the sketch first, and then I go and figure out how can I describe this sketch. Okay. Yeah. So don't be confused. See, 哎呦，怎样来哦？考试肯定想不出这个东西了。考试 ，okay. Let me tell you 考试 how about 考试If 考试 you really cannot write this form at least you need a picture to convince me how you can build this thing. Okay. At least you need to have some idea to convince me how you can build this thing. Obviously, you cannot get full marks, but maybe you can get most of the mark if your explanation makes sense. Okay or not? Yeah. Does it make sense? Okay. No need to find hard to compute this thing. If you come up with this, the formula will naturally come on. Okay, yeah, will naturally come. I won't give too exotic counterexample. 会很奇怪的那种，肯定是你有看过、你有做过的东西。OK 吗？明白吗 ？Yeah. Maybe one exercise I gave to you is whether you can verify this formula give this shape or not. Okay. Yeah, if not, whether you tell me soon. I think it explain, but if not, you tell me. Yeah. So this is like what? 好像 Like what? What is this? Maybe like a stock. Like a stock. 没有睡不着，昨天很好。Okay, right. Good. Okay, next question here. Okay, this question are actually not long one, only 3 line only. Huh? What? Yeah, let me explain to you. So suppose A is greater than 0. Okay, we want to prove that this series here is not bounded or diverges to 0. Okay, what does it mean? How to prove it? So I give you the definition. That is to prove that for every m that exists in n such that Sn greater or equals to n. So meaning what? And for all come first, meaning you need to start with any m first. Take an arbitrary m. And then find the n. So you need to find the n. How to find it? Don't go find first. Go and see what you want to prove first. So you need to satisfy this first. So right now, what you need to satisfy first. Only then you can go and find n. Don't just go simply find, correct or not? 你要知道你这个 n 来干嘛先，才可以去找 n， 不要直接去找 n， 明白吗？这是讲，这就是怎么读这个 statement。Such that 这个 part 是最重要的，因为你就是要 prove 这个东西 true。OK 吗 ？So we decode the such that first. We decode this part first. How do we decode this? I gave you formula already. What is Sn? Sum of A from 1 to capital N. But what is this? Just capital N A, right? You want to make sure that this is greater or equals to M. This implies what? N is greater or equals to M over A. So you need to find an N that do this. But what does this hint say? For every real number x, there is a natural number. I don't know which one. It just said there is a natural number such that what? S is less than N. So if you want to use this Archimedean property here, what S you can take? You want to find that N. If you have this S, you have an N. So what S you can set? Not just M, right? You want to set S to be M over A. Why M over A is a real number? M is what? M is the one that you fix already before. You already take. So you already take a M. So M get fixed already. A, right? A fixed already or not? A also fixed already, question. So two fixed number divide again, still a real number. By Archimedean property, you have an N that greater than that number. Done? Can you see or not? Can you see the logic? The logic is very important here. Okay, I already give you all the puzzle already. You just need to put together. You don't need to think much one. Don't need to go simply find this N. People give you already. But what is this N? Actually, this N can vary, you know, in this Archimedean property here. How to vary? Think about this statement. What does it mean by there is a natural number such that S less than N? For example, what? A real number that you know. We talk about a lot of real numbers today, right? So what real number you want? Pi, for example, pi. So what is the N that greater than pi? 4, but must be 4, not. No, 5 also can. If 4 works, 6 also can. But I don't care. I just care that exists and N is enough. That exists. I don't care what N is it. Okay or not? Isn't it nice? Nice. Very nice. Okay. Yeah. So I pay attention to my hint. The hint I gave you 好了了，好了，要用 ，OK， 好了了。So pay attention to hint and pay attention to what I can let you assume. Will set you time on. For example, the first question I say no need to prove F differentiable imply F continuous. If you're going to prove, you need to use epsilon delta. So save your time. So you need to pay attention what you can assume, what the hint tells you. No need to prove hints. Okay, if you like to prove hint, that one is extra work you choose to do. But I won't assess one. Okay. But hint meant for you to use and then give you direction. Give you direction. Can you see direction or not? Because this question asks you to prove that exists. This hint tells you that exists. Almost telling you the answer already. Only if you can see it or not. Okay. Does that make sense? Okay. Yeah. Okay. Okay, so this is the question. Okay, about question 3. So question 3. I took inspiration from one TV show, which is called it's from CCTV one. Not sure it's CCTV or Zhejiang Weisi. It's the 圆桌派. You can go and watch. Talking about 量子力学. 圆桌派 is the, you know, 看向三人行. Don't know. So it's a talking show. So the famous host make a TV show in China called 圆桌派, and then they discuss about this, about quantum physics. So I take inspiration from there. So I said that a Chinese philosopher Zhuangzi mentioned that if you take a ruler of length 1 and you halve it every day, it will remain inexhaustible for eternity. Okay, so you keep halving it, but you still can halve it. Okay, you still can halve it infinitely many times. Very enough. Okay, so this is spoken by a famous philosopher, Chinese philosopher Zhuangzi. But so I ask you to explain, okay, whether it is possible mathematically or not, okay, or is it possible physically? Okay, if you really take a wooden stick and then you halve it, halve it, halve it, halve it, and halve it. Can you keep halving it? You say cannot. Hey, your answer say cannot. Oh, your answer say cannot. What? How much? How many marks I give you? 2 marks. Okay. So this open question is about how you explain, how you convince the people. If you just write one line, how people can get convinced in this one line? Almost impossible. Okay, so you need to elaborate because I associate 3 marks to it. What's next? You guys have class. Can we finish in 2 minutes? Sorry. Okay, maybe we finish discuss this and then we continue discuss next time. So, how do we do this? So first, mathematically, you can imagine as a series. This is the first series I introduced to you, right? I take half, add 1/4, 1/8, and then keep adding until the infinite sum is 1. So this is the other way around. I start with 1, take away half, take away 1/4, take away 1/8, and so on. Okay? But, okay, I want to talk about this physics view first before we finish. So imagine, how do you cut this ruler? Either you use knife or scissor, a very sharp thing to cut it. Right or not? You need to apply pressure to cut it. So you imagine you cut until very small, until maybe atomic size. How do you cut it? Actually, what they do is use atom. They use very fast speed atom to hit the bigger atom. And then the bigger atom will split. Okay? And then the split, that's the time where they have these zoo of particles, the period of discovering zoo of particles. So they discover a lot of particles. So then when they split, they will emit what? Emit light, emit energy. Okay, and then this energy will turn into mass again. Okay, so when you hit the particle, it makes more particles. But how far we can do it? How far we can do it? This is the goal. This is the how to say. This is the inspiration where we built this sun. You know sun. You know sun. There's a hadron collider. So they built a very large accelerator where they can accelerate photons, atoms, and then hit the particle. But they hope to gain new insight on this atom. But turns out that they cannot produce even more energy now. For the energy they can produce, they can't really find anything new. Okay? And then after that, they resort to see whether this atom can be built by string or not. And they propose a string model to describe atom. So this is what called the string theory nowadays. Okay, if you're interested, you can read it. And we will continue next Tuesday.